All right, this lesson is on annuities, or you may also be familiar with superannuation. Superannuation is an annuity. So the definition of annuity is it is a regular contribution to an account that earns compound interest. So, for example, a regular contribution means something like that you're putting in regularly. So just say you're putting into an account $100 every month, or $100 every birthday, or something like that. That's a regular contribution. And each contribution that you put in that account will earn compound interest. So if you're earning compound interest on each single contribution. So to find the value of the total investment, we are going to add up all of those different compound interest payments. That's what it's saying here. We're going to sum the compound interest payments. And when we do that, we end up with a pattern. And you'll find that there is a GP in that pattern. And then because we're adding up these GPs, we can then use the sum of the GP to help us add up all of those regular contributions to find the value of the total investment. Okay, so let's have in all these questions that you get, it's really important that you underline keywords and key information, just like when we were doing the compound interest lesson. So when Susan was born, her father deposited $130 into a trust account, earning 12% per annum interest compounded annually. So the first payment was when she was born, and it was $130, and that $130 is earning 12% per annum with interest compounded annually. He then decided to deposit $130 into this account each time Susan had a birthday. So every time she has a birthday. So that makes it a regular contribution, which is what an annuity is. And he made his last payment on her 17th birthday. All right. Show that the initial deposit of $130 amounted to $999.70 on her 18th birthday. So the first deposit of $130 is going to earn compound interest for how many years? If it's put in when she is born, and then we've got to show that it equals this amount on her 18th birthday. So that is obviously going to be when n equals 18. We've got the principal is 130, and we've got the interest rate up here is 12% per annum compounded annually, so it's just 0.12. So we're just going to substitute those amounts into the compound interest formula, and you can see the working out that I've got here for that. At A1 is that first deposit of 130 times 1 plus r to the power of 18. That little 18's been cut off. And when you put that in your calculator, you get $999.70, which is what part A this question has asked you to show. Then part B says calculate the total amount that was in her account on Susan's 18th birthday. So the father is putting in $130 when she's born. He's putting in another $130 on her first birthday, another $130 on her second birthday, all the way up to the last payment, remember, on her 17th birthday, which is going to be the 18th payment, because remember the first one was when she was born. Okay, so it's really important that you set up a little pattern like this with words and what the payment number is. That'll help you to set up a series as well. Okay, and so on her 18th birthday, he puts in the last, on her 17th birthday, he puts in the last $130, and that $130 is only going to earn interest for 1 year, so that's why it's to the power of 1. Whereas, I guess starting at the very beginning here, the one she was, the $130 contribution when she was born, that's earning interest for 18 years. The one on her first birthday will be 17 years, and then it'll go down each time. All right, now it's very important that you set up a series like this because every question is going to be different. The last payment could be earning interest for a year, or the last payment could be just deposited, and then the question says, then how much that is in the account. So it's really important that you set up a pattern like this. All right, then the question says calculate the total amount that was in the account on her 18th birthday. So the total amount that is in her account is going to be the sum of all of these different contributions. Each one is earning compound interest for a different amount of time. So if you can see, it's 130 times 1.12 plus 130 times 1.12 squared plus 130 times 1.12 cubed, etc., all the way up to 130 times 1.12 to the power of 18. So when we're adding all those together, you can factorise out the 130, which is what I've done here, and then you can see in the brackets here, I'll just move that up a bit, I'll see if I can, is all of these amounts that are, which button do I need, sorry, all of these amounts here, these indices. So we've got 1.12 to the power of 1, 1.12 to the power of 2 would be the amount on her 16th birthday, etc., all the way up to this one here, which is the one from when she was born. And you can see what we have here in brackets. We have the sum of a geometric series, where the first term is 1.12, and the common ratio, you can see 1.12 squared divided by 1.12 is 1.12. So we have our first term is 1.12, our common ratio is also 1.12, and the number of terms, well, if you put the power of 1 up there, you can see that there's going to be 18 terms, because we're starting at n equals 1, and we're going from n equals 1 all the way up to n equals 18. So there's 18 terms in that geometric series. So using the formula for the sum of a geometric series, sum of n terms, is a outside of r to the n minus 1 all over r minus 1. So using that formula for the sum of a geometric series, let me shimmy this up a little bit more. Oh, that's moving with us, that's pretty cool. There we have it. So we've got 130, which was that 130. Then this inside the brackets is the sum of the geometric series, which is here. There's our a, there's our r to the power of n minus 1 on top of r minus 1. Then you just need to put that in your calculator to see what the total is. And that's going to be $8,117.16. So quite a lot of money just from depositing $130 every birthday. Enough to buy a car, probably. Good start. Anyway, that's for sure. All right, let's have a look at another example. What's the working out for this one? All right, here. At the beginning of each year, a man invests $1,500 in a super fund. So that's at the beginning of each year. Important because sometimes in some questions people are putting money in at the end of the year. Okay, and which he is paid 10.5% per annum interest. Find A, the total amount of interest for the first year, and then B, the total of his investments. So the total his investments amounts to after 20 years. All right, so let's just move up my solution. We've got here on the right-hand side the solution for part A. So using the simple interest formula, because the part A is just asking for the amount of interest for the first year, amount of interest, which is I, which equals PRN. So P, the principal, you can see there he invested $1,500 as our principal. Our rate is 10.5% per annum, which is 0.0105, and our N, which the amount, the question's just asking for how much is in the first year. So there it is. That's one way of doing it. Another way of doing it is by using the compound interest formula, but the question, remember, is asking for the amount of interest. So the compound interest formula gives you the final amount including the interest. So if we were to put this in, we'd have $1,500. 1 plus r is 1.105, and then to the power of 1. And if we put that in our calculators, you'll see that we get $1,657.50. Now that's the amount including the principal and the interest. So to work out the interest, we have to subtract the principal from the final amount, from the amount that includes both the principal and the interest. So 1657.5 minus the principal of 1,500, and you get the same amount of interest we got with the simple interest formula, 157.50. So that's just another way of working out the amount of interest. Right, now part B, this is what we really want to do. Find the total amount his investment amounts to after 20 years. So he's putting in $1,500 at the beginning of each year. So it's a regular contribution, which means it's an annuity. So let's set up the pattern. The first amount, A1, $1,500 is the principal, and that's going to be earning interest for 20 years because the question is saying is putting the money at the beginning of the year and it's asking how much is in the account after 20 years. So that first $1,500 is going to be there for a total of 20 years. The second $1,500 will be there for 19 years, etc., all the way down to that last $1,500, which is put in at the beginning of the 20th year and earns interest for 1 year. So then you can see the total that his investment amounts to is the sum of A1, A2, A3, all the way up to A20, which you can see I've written out along there. Next step, I've factorised out the 1,500, and then you can see in brackets we have here the sum of a geometric series, where you can see the first term is 1.105, and the common ratio is the ratio between the second term and the first term, which is also 1.105. Looking at the powers, we've got from power of 1 all the way up to power of 20, which means there's going to be 20 terms in that series. So substituting into our sum of a GP formula, which we have here, we have this, and then we just put all of that in our calculator, and that'll give us the total amount of his annuity at the end of 20 years if he's putting in $1,500 at the beginning of every year. So $100,000, $100,495.56. $1,500 every year. So when are you going to start an annuity for yourself?